the unit of interaction between the ILA client and the ILA implementation through the reading API. It's an interval of time during which tags are read. At the conclusion, as I mentioned, it's sending a report to the client what tags he has collected, and the client before it specifies what tags he needs. So in order to help the event cycle to see what kind of data he is going to reply back to the client. As tags moved in and out of the detection zone of the reader, tag data reported changes. So if we take a look on this picture, we can see that we can have multiple event cycles simultaneously, and every time, during every reader cycles, reader can read the same tag again and again, and after all they have to filter and to send all to the client as a report. Event cycle has the following attributes. It has logical readers, what logical reader or other devices to use to read the tags, logical names, not physical, which means that we are defining one logical reader name, and this logical reader can be or one reader, can be multiple reader, or can be one reader that has multiple antennas. Also, we are defining in the specification the start and stop conditions. The start and stop conditions can be duration, a start trigger, and the stop condition can be when the duration finish, it automatically stops the event cycle, or stop trigger operation as well. And report specifications, what filters to apply, what filters of data to read and to report. So, what I have done is to extend the functionality of the application layer event in order to be able to divide the event cycle between the neighbor readers. So, for this purpose, I create a neighbor reader manager object, which is responsible for, which is the central point of controlling neighbor logical readers, and it is spawning one thread called manager thread. What the meaning of this manager thread is to check how many event cycles are subscribed, check how many logical readers are subscribed, to calculate the respective duration of each reader. We have to be fair in order, not to give to one reader more time to read and another reader less time. So we have to divide it in the they have to, all the readers has to have the same time of duration, and also it provides a functionality to update the row spec of each reader, which means that we can update the neighbors on the the logical readers on the fly, and after doing all this calculation, it starts to orchestrate the logical readers, which one is going to read, which one is going to wait when it's time to come, and it will start reading. And also it has a functionality to stop the logical reader reading cycles. So algorithm of division are the following. It gets the duration of all subscribed event cycles for this specific group, chooses the minimum event cycle duration, checks the number of the logical readers, and checks the boundary specification and divides the minimum event cycles between these neighbor logical readers. But the important thing here is to check the boundaries, let's say, because if we have a lot of readers and the neighbor readers and the event cycle duration is small, it will give to each logical reader very small amount time of reading, and most of the time our application will spend to changing this from one reader to another, and this way our system will not have a high throughput and good functionality. So if you take the the schema of my solution. As I mentioned, we have in this picture we have two managers, neighbor reader managers. One has 3 readers, another has 2 readers. Each reader is subscribed for specific event cycle. So the important thing in this graph is to mention that different readers in different groups can be subscribed to the same event cycle. For the future work, we have to also try to implement when one reader in specific group can subscribe in one reader can be in 2 neighbor reader managing group, which is maybe I will do later. So speaking about the logical API, it's the interface through which client may define logical reader names for use with the reading API and writing API. It provides for the manipulation of configuration properties associated with logical reader names, and logical reader are abstract names that the client uses to refer to one or more logical readers or antennas. One reader that has many antennas. So there are 3 types of the logical readers: composite reader, externally defined base reader, and API defined base reader. If you take a look to the specification of the logical reader, it has a fields like description, the connection point address or IP address where the reader is